Welcome to Brain Vision.
So here it's saying that we have n equals n, just n equals n mole of hydrogen gas and neon. So it's saying that we have 300 joules. 300 joules was added to n mole of H2, so hydrogen gas, and it raised the temperature by 2.5 degrees Celsius. So at this point, we can say that the change dq equals, and what this formula is saying is that the dq, the amount of heat required to raise the temperature by dt, is going to be equal to n, the number of moles, times the molar heat capacity at a constant volume of that molecule, times the change in times dt, the change in temperature. We're going to have to find the CV, so the molar heat capacity at a constant volume for hydrogen gas is going to be equal to the DOF over 2 times R. And the degrees of freedom, DOF, simply means in how can it orient itself how can the actual molecule orient itself differently in how many dimensions, essentially. So with hydrogen, it's 5, so it'd be 5R over 2, and it's going to become, it's 3 of them. 3 of the degrees of freedom come from translational motion. So any atom, any molecule has at least 3 degrees of translational motion, because of course one atom can move in the x direction, the y direction, and the z direction. And then we have to consider rotational. So rotational degrees of freedom occur with diatomic gases. There are 2 degrees of, for diatomic gases, there are 2 degrees of rotational motion. However, when you look at the neon, a neon is only 1 atom. So if you were to model the neon as a sphere, there's no such thing as a rotational motion with neon. So we can say that CV of neon is going to be equal to 3R over 2, and that's only because, again, there's only 3 degrees of freedom. A molecule can only, a single atom rather, if it's modeled as a sphere, can only travel in the x direction, y direction, and z direction. If it were to rotate on any of these axes, it wouldn't really change the axes at all. So it wouldn't really change the sphere. So the orientation of the sphere would stay the same if you were to rotate it, of course. Rotating a sphere would not really change the appearance of the sphere. However, with a diatomic gas, let's draw this. This is very rough. It can rotate on this axis. So that would be rotating about the y-axis. It could rotate about the z-axis. However, if you were to rotate it about this axis right here, if you want to call that the x-axis, it's going to stay the same. And you can see this in a model, in like ball and stick model. If you were to rotate it, along the axial direction here, it's not going to change the appearance. So that's why one of the rotational degrees of freedom is knocked off. It should have, in a very complex molecule, it would have 3 rotational. It would have 3 rotational degrees of freedom. But in a diatomic molecule, one of the degrees of freedom is knocked off. So we only have 5. So 5 total degrees of freedom for H2, and then 3 total degrees of freedom for neon. And at this point, we can say that the amount of heat required to raise the temperature by dT is going to be equal to the amount of heat. The amount of heat required to raise the temperature by dT for hydrogen is the same amount of, it's the same amount of heat. So dQ is going to be equal. dT is what we're trying to find, essentially. So if we can say dQ is equal to NCV neon, and then equal N dt. These both right here are equal to each other. The question is asking if the same amount of energy was added to the hydrogen system, and that raised it by 2.5 degrees Celsius. How many degrees Celsius? What's the temperature increase when we add 300 joules to the neon system? So if we were to set these equal to each other, we have NCVH2 dTH2 equals NCVNE dTNE. The number of moles is going to cancel out. They're both the same. And then we have 5R dTH2 divided by 2 equals 3R dTNE divided by 2. And this is going to be equal to, we need to isolate this variable. So when we isolate this, this is going to be equal to 5 dTH2 over 3. Again, these R's cancel out. So let's do it. So at that point, we can say dt NE equals 5, and then this is going to be our 2.5 degrees Celsius. So we'll have 2.5 degrees Celsius over 3, and this is going to be equal to 4.167 degrees Celsius. So if you were to add 300 joules to the neon system, instead of increasing it by 2.5 degrees Celsius, that was the temperature increase of the hydrogen system. Here, it would be a 4.167 degrees Celsius temperature increase in the neon system if the same amount of heat was given to the neon system. So again, this will be our final answer. And that's the end of the solution. Thank you for watching.